This is the poster presentation for the Polymer Technology Center sponsored project. The objective of this project is to design and manufacture a strand cooling mechanism for filament extrusion. The Polymer Technology Center wants a solution to cool extruded hydrophilic polymers. Some of the hydrophilic polymers composition can be ruined by the absorption of water during the cooling process. As an alternative, an industrial air unit will be used to blow cooled air over the extruded filament as it is moved over the conveyor system. The requirements of the system are as follows. The entire system needs to be mobile, must not exceed 20 feet in overall length. The extruded filament must be cooled to at least 100 degrees Fahrenheit. The system must have variable speed, and the system must use a standard 120 volt wall connection. For verification of these requirements, the following verification steps correspond respectively. Locking caster wheels will be used. The prototype will be designed and measured to be under the specified length. The filament will be monitored throughout the system. The conveyor will be configured with a variable speed control. And finally, the system will be designed to run on a 110 volt power supply. The conveyor belt system will be used to transport molten filament from the extruder to the pelletizer. Over the length of the belt, the filament will be cooled to a handling temperature at which it can be cut. The conveyor will utilize an RMC synthetic rubber to accommodate the high temperatures. The belt will be run over pulleys powered by a half horsepower motor using a 40-to-1 right angle speed reducer. The conveyor will be manually controlled within a range of 5 to 25 feet per minute. A hood will be installed over the belt area to direct air over the working surface. For the cooling system that will be incorporated into the conveyor, an industrial grade portable air conditioning unit will be used to cool the filament. The airflow produced by the unit will be ducted into the hood and over the working surface of the conveyor belt. This is projected to cool the extruded filament from about 400 degrees Fahrenheit to a required handling temperature of about 100 degrees Fahrenheit. A lesson permanent magnet motor will be used to produce 12.6 pound-inches of torque. This brush motor has a shaft diameter of 5/8 inches. This will also be controlled by an iron horse DC drive motor controller. For the electrical sensor system, a pair of Raspberry Pi Model 4Bs will be used to monitor the MLX IR temperature sensors, display information to the operator, and toggle the permanent magnet motor on and off. Shielded Ethernet cables will be used to establish smooth data transmission and deliver power to both boards. Moving forward, our final steps of the project will be the fabrication of the final design, then verification, adjustment, and the testing phase using live filament runs. The OSHA standards that directly apply to our conveyor belt can be seen in subsections 1 and 3, specifically relating to the audible warning signal that is sounded immediately before startup of the conveyor and the emergency stop switch. And finally, the PTC Filament team would like to express our sincerest thanks to Dr. Charles Lee, Dr. Thomas Cott, and Dr. Terrence Fagan for their insight and guidance